This is the Excel file that we'll be using in this demo. It's essentially a database of Major League Baseball players and their statistics. As you can see, their statistics are along the horizontal axis there, so to speak, along the top, seasons played, games played, etc. And all the players are listed in the different rows. Specifically, we're going to use a statistic or a characteristic called primary position played. That's a categorical or qualitative variable, and so we're going to use that. Now, going forward in the other worksheets, we're going to simplify this significantly, and let me show you what we're going to do. You might want to do this with your Excel files. When you have a number of columns that you really don't need and they just make your worksheet wider than you'd like, you can hide the columns, not delete them, but you can hide them, and then after you've hidden them, if you want to see them again, you can unhide them. So let's talk about doing that. If we don't want columns B through, let's say, X, you can highlight those columns by going along the top there, right click with your mouse and select hide, and then all we see is the players' names, their primary position, and those two on the other side of the primary position. And we can hide those as well because we're not really going to need those. So we can go along like this and then right click and hide those two. So that makes the file a lot more usable. So you might want to do that with your files as well. Let's take a look at the next worksheet here where we've done that, but we've added two columns here, one for generating a random number and one for fixing that random number. So let's talk a little bit about that. Going to column B2, let's take a look at the formula there. It's using the RANDBetween function. In this case, it's asking Excel to calculate and input a random number between the numbers 1 and 99, and that same formula is copied in each baseball player's row. The next column over is where that number is fixed, and so the way that Excel treats that RANDBetween function is it keeps calculating a new random number every time you click on the keyboard or a mouse or whatever. So we ask it to do it one time, and then what we've done here is we've just taken all these numbers here and copied them into this column. Somebody has done that previously. And then you'll notice that Excel is sorted here on this column, and it's got this column C in smallest to largest sequential order here. So keep in mind that all these ones here and twos and threes, those were randomly assigned to each of these different baseball players. Okay, and as a reminder, here's the primary position played. As you can imagine, a 3 is third base, a 2 is a second base, and a 1 is first base. O for outfield, S for shortstop, C for catcher, and so forth. Let's go to the next worksheet. Notice this one is the Hall of Fame SRS, simple random sample, a calculation of 50. We're going to use a sample size of 50 for our purposes here. And what we've done is just selected the first 50. Here's the random number fixed, and so we're just going to stop right here at row 51. And remember now, these are randomly attached. These 3s and 4s and 2s were randomly attached to these players in column A. Scroll down just a little bit further, and we will see that we've written some calculations here to determine what the percentages are for the different positions. So let's take a look at this formula here in column AA and row 55. It's going to count up how many O's it sees in all these rows up here that are in column AA. So from AA2 to AA51, if there's an O there, it's going to count it and divide by 50, and that will give us our percentage. And so our simple random sample is generating a 38% of outfielders, an 18% of catchers, an 8% of second base, etc. Let's take a look at using a stratified approach. Here is our kind of back to our database. Here's the random number that's fixed. You notice column B is not showing. That's the actual random between function column. No reason to see that at this point. And so here's what this shows at the bottom. We're going to stratify here on how many years the baseball player has been in the big leagues. So we have one strata of 10 to 14 years, another strata of 15 to 19 years, and another strata of 20 plus years. And let's take a look at this formula for how the 67 and the 28 and the 5% was calculated. So what it did here is it went through column D from D2 to D1340, and if the number was less than 15, then it counted it, so it counts all those up and divides by 1339, which is how many baseball players are listed there. And so there were 67% that were less than 15. And likewise, the less than 28 falls, between 15 and 19, we would write this kind of function here. You can come back and take a look at this a little bit later. And greater than 20 years, you can see there's greater than 20 right there, and it's dividing it by the total to give us a percentage. What we're going to do is then we're going to convert that as to a hard number as a percentage of 50. So we're going to, the formula here that gives us the 33.64 is to take D1343, which is this, and multiply that by 50. So 67% of 50 is the 33.64. And likewise for these. So if we round those, round that 33.64 to 34, and the 13.97, of course, to 14, and we'll round that one down to 2. So let's go through and take a look at the different strata. Here is a strata of under 15, and these are highlighted in green. So here's the entire list, but just in green is our under 15. The next one is the between 15 and 19, and that's just going to be those 14 right there. And then the next one is just going to be our 2 more than 20. So the next one we're going to look at is where we've put all those together. Here is the worksheet with all the green under 15 years, and then the 14 that are between 15 and 19, and then those 2 greater than 20 years. So here's where they all are together. Let's see at the bottom what the calculation tells us about the percentages. So the stratified sample here generates a sample with 34% that are outfielders and 16% that are shortstops, and 20%, the 0.2, is the number of catchers. So let's go to this summary side, and this gives us a comparison of the population with the different kind of sampling that we've done. So you can see the table there. I'll let you take a look at that. But the bar chart that is below it indicates how well the samples compare with the population. So this is those bars in that chart represent the difference between the population and the different samples. So you can see that the stratified in the red consistently has a bigger difference from the population than the simple random sample one there. So I think we can state our conclusion fairly confidently here that the simple random sample method produces a sample that aligns much better with the population, that is, has less bias than the stratified sampling method. That's the end of our demo.